This video is part of a series of tutorials. If you got here by chance or by searching YouTube to understand science, in particular chemistry, then you are on the right channel. I am a retired chemistry professor and would like to share my knowledge to all who are interested in learning chemistry. Please like, give a thumbs up, and subscribe to my channel. Hit the notification bell if you like the video so I can make more content like this. Thank you. On with the video. In this video, we'll cover scientific method. Scientific method is a method or way of solving problems in a logical manner. Problem, in my opinion, should always have a solution, and that's what scientists do, to find that solution. Chemistry is a science, and so it uses scientific method to solve problems relating to chemistry. It starts with an observation which we can see or measure. Here scientists collect data. Data can be qualitative, which we can see, or quantitative, which we can measure. Technically, it means that qualitative observations involve descriptions of the nature of the substances under investigation, and quantitative observations involve making measurements to describe the substances under investigation. And from our observation, we ask a question or several questions, do research about the observation as well, and we make guesses to answer those questions, and so we formulate what we call hypothesis. Hypothesis is an educated guess of why things behave the way they do, which can be very specific or it might be broad, and which could be a possible explanation to the problem. To verify if that educated guess is correct or not, we perform an experiment or a series of experiments. Experiment is designed to test the hypothesis in how correct is your guess or guesses. This is the part where we reject or accept a hypothesis, or it could lead to new observations. Experiments happen normally in the lab, and the cycle goes on. When a hypothesis is accepted as true by the scientific community, it is then called a theory. After many cycles, a broad generalizable explanation is developed for why things behave the way they do. This is called analyzing the data and making a conclusion and finally announcing the results. Another term to explain is scientific law. Scientific law is a statement that generalizes a quantity of experimentally observable phenomena. For example, if a person drops a pen, it falls downward. This result is predicted by law of gravity. One of the most important scientific laws is the law of conservation of mass. This states that during any process of chemical reaction, physical change, or nuclear reaction, mass is neither created nor destroyed. The concept of mass is central to the discussion of matter and energy in chemistry. The mass of an object depends on the quantity of matter in the object. Because of the close approximation of mass of an object is the quantity of matter it contains, the law of conservation of mass can be approximated by the law of conservation of matter. Let's take one example. A piece of iron that is left in moist air. Its surface will gradually turn brown, and the object gains mass. Does this mean that the piece of iron with rust is heavier than the one that has no rust on it? By just looking and measuring its mass, you would say yes, but the correct answer actually is no. Let me show you the chemical equation now. Chemical equations, by the way, are symbolic representations of chemical reactions in which the reactants, which are on the left side of the equation, and the products, which are on the right side of the equation, are expressed in terms of their respective chemical formula. This will be discussed in the upcoming videos. For now, let's go back to the example. The brown material is a product of the chemical reaction, which is on the right side of the equation. This is called iron oxide. This is rust. This is formed by the reaction of the iron with the oxygen in the air. The increase in mass is just the mass of the combined oxygen and iron. This follows the law of conservation of mass, in that mass is neither created nor destroyed. I will see you in the next video, and thank you for watching.